Hey everyone, we are on to lesson 8. We're doing part 2 of this lesson today, which carries over from last week, and we're looking more at hanger diagrams, how they relate to equations. And today we're going to look a lot at equations that could be solved by using the distributive property. In our first activity, I want you to take a look at this, please. It says select all the expressions equivalent to 2 parentheses x plus 3. All right, now before you do this, before you identify those equivalent expressions, remember with the way this is written, we have a quantity here in the parentheses and all of it is being multiplied by 2. So find those equivalent expressions. All right, now since we said that everything here in parentheses is being multiplied by 2, then we need to be looking for equivalent expressions that are showing us 2 x's and 2 3's being added together. So let's look through. First, I noticed this one, which looks almost identical. The only thing that they've added is this little dot, which we know represents multiplication. That would definitely be equivalent. With multiplication, we can switch the order of the multiplication. So if we put the 2 at the end here, that one would work. And then if we look at this next one, we are taking 2 times x plus 2 times 3. And that is definitely what's happening here. We have 2 x's and 2 3's. Let's look at the next 3. So for the next one, we have 2 times x, looks good, plus 3. Because we're missing the parentheses, we're not multiplying 2 times 3 here, and that's going to make it not equivalent. Same for the next one, is we are taking 2 times x, good, but then we're just adding 3. We need to be adding 2 3's, so that one's not going to work. And here, this one seems like it should work. We still have the parentheses, we're still multiplying. But the problem is now we're taking 3 of everything here in parentheses. Now we have 3 x's and 3 2's, and that wouldn't be equivalent either. Now moving on, we've got another hanger diagram here, and it says explain why either of these equations could represent this hanger. So let's take a look at it. Remember, this is completely balanced. The left and the right side are balancing out one another. So this value of 14 has the same weight or the same value as this side of the hanger diagram. So let's look at the equations. We have 14 equals, that's good, that's representing the left side. 14 equals 2 parentheses x plus 3. So remember, that's 2 x's and 2 3's. And if we look at the right side of the hanger, I can definitely see 2 x's and 2 3's. So this would be a good representation. Next, we have 14 equals 2x plus 6. And if you notice, they're just writing this version a little bit differently. What they're doing is they're combining those x values into 2x, and then they're combining the 3's and just calling it 6. Nothing wrong with that. It's definitely equivalent. Now what we have to do is we have to find the weight of one circle or one value of x. So let's use the diagram to do that. I'm going to take this off of here. And there's multiple ways to look at this. If we were solving this more like an equation, we might think to get rid of these extra 3's that are here. So we would take 6 away from this side and 6 away from this side, and that's a perfectly fine way to do this and a great way to start. The other thing I want you to notice, especially if you're looking at the equation this way, is it's telling us that we have 2 of the same groups, and I can see that right here. I can see one group of x plus 3, a second group of x plus 3. And if we start right away by just eliminating one of these groups, we will still have an x value to find the the value of, which is what we're trying to do here. So essentially what we're doing is we're just lopping off the bottom half of this diagram. If we get rid of half of the groups here, this x plus 3, then we need to get rid of half of the value over here. That means that we're going to get rid of 7, or half, of the 14. So it will leave us with 7 equal to one group of x plus 3. Now, if we do that, we still have this excess of 3 here that we need to get rid of, but we must balance it on the other side by removing 3 from the left side of the hanger. If we get rid of 3 from 7, then we're left with 4, and that is what's going to be balancing out the x. So x equals 4. Let's look at the next one. It gives us another equation. It wants us to use the diagram if we choose. We don't have to. So we could solve this. We could use distributive property because we have 3 times these two values here. So we're going to have 3 x's and 3 4.5s, and that certainly is evident here in the diagram, or 3 groups of x plus 4.5. So we have 3 x's in total and 3 4.5s in total. If we use the same method that we talked about here, what we're going to do is we're going to immediately eliminate these 3 groups. And instead of considering 3 of them, we're going to remove this lower part of the diagram and just deal with the top. All right. To do that, we have to figure out the value of one of these groups. So if the entire hanger diagram shows that these 3 groups is equivalent to 36, then we need to divide 36 into 3 equal groups so that we can see their value. So 36 divided by 3 is 12. So that means that each of these groups, we'll scribble out that 36, has a value of 12. So if we eliminate one of these groups, we eliminate a third of this total. We eliminate this group, we eliminate 12 from this side. Take off another group, take off another 12. And now what we're going to do is we're just going to focus on this. What that's leaving us with is an equation that looks like x plus 4.5 equals 12. Now look back at that original equation. Remember, here we had 3 of those groups. One way to solve this would be to just get rid of that times 3. What that means is we would divide this side by 3 using the inverse operation, do the same here, and we would be left with this equation as our one-step equation that remains. Okay, of course, the next step would be to get rid of this plus 4.5 so we can see just what the value of x equals. That's what we're doing here in the diagram too. We'll get rid of this extra 4.5. Of course, we have to balance it here by subtracting 4.5. And now what we'll have is a value for x that equals 7.5. And that would be our solution. All right, let's take a look at the next situation here. I'm going to do 2 of these for you and kind of keep demonstrating the idea. Then I want you to do the next 2. So first, we're asked to match a diagram to each of the 4 equations here. Now, the funny thing is they use different variables for each of these. So clearly, in each of the equations, they're using a different variable. There's not a lot of mystery here, but we do need to be able to see how these equations match. So this one, 2 groups of x plus 5 equals 16. Now, it'd be pretty clear looking at these 4 diagrams, we only have 1 equal to 16, and then we definitely clearly have 2 groups of x plus 5. So A is definitely a match to this situation. Okay, if we continue on, we have 3 groups of y plus 200, 3 groups of y combined with 200 equals 3,000. That's definitely B. And we can just match up the other two as well. So we have C and D here. Now, the big point, besides recognizing how these equations describe the tape diagram, or the other way around, how the tape diagram represents those equations, we also have to be able to use it. We have to be able to solve it for the variable. So for A, which is where we're going to start, I have my 2 groups equal to 16. Okay, immediately I can just focus in on one group, and I would do that here in the equation by dividing both sides by 2. That's the inverse of what's happening here. This group is being multiplied by 2, so I'll cancel that by dividing it by 2. So I could do that. And if I do that, if I divide it by 2, now I find that one group is equal to half of this value, this weight here on the right. Instead of being 16 for 2 groups, it's going to now be 8 for the one group. So a missing quantity plus 5 equals 8. Hopefully you can see that here x is equal to 3. All right, now I'm going to leave B and C for you and then jump to D, the one with the fractions. But again, we have 2 groups here. Notice that for B and C, we have more than 2 groups. Here we have 3 groups and 4 groups. So in this case, you would divide it into 3 groups, this one into 4 groups. So just keep in mind that that's going to be slightly altered, still the same idea, but slightly altered from the 2 examples that I'm showing you. But here with the fractions, our 2 groups, we have a W plus 2/3 and another W plus 2/3. It's all combined, these 2 groups equals 20/3. So let's split it up and focus in on what one group equals. Again, if I were to rewrite that, just with the one group, I would write W plus 2/3 here on the right-hand side is equal to now half of what the quantity used to be. That was 20/3 was the entire bar. 10/3 would be half of that. And now I just need to get rid of this extra 2/3 that's hanging on to that variable, the part that I don't need to know. The 2/3 is the part I already know. Let's get rid of it. So let's subtract 2/3 from here. And we'll subtract 2/3 from here. That's going to leave us with 8/3 as our value equivalent to W. And it's fine to just leave it as an improper fraction like that. Okay, give B and C a try, please, and then check the notes for the answers to those 2 examples. Okay, onto the back of your sheet, we've got a little more practice reviewing the distributive property again. Now we're not dealing with the hanger diagrams. If you want to practice drawing those, I would of course encourage you to do that. But we also want to be able to see this equation, maybe picture a hanger diagram, and solve it in the ways that we just talked about. Now, at some of these equations we talked about using the distributive property. So we can certainly do that, and if that's the way that you're more comfortable with, if you would rather distribute first and rewrite the equation with an equivalent amount, that's fine. And just to remind you how to do that, remember we're talking about 3 of these groups of C plus 5. So we have 3 C's and 3 5's. That's all we're doing is we're rewriting it as 3 C's and 3 5's we would just write as 15 equals 12. Okay, Then we would do our 2 steps. This is a 2-step equation because we have 2 operations, addition and multiplication here. We do our 2 steps of doing the inverse operations and balancing it over here on this other side, on this running total that we have, and come up with what C equals. But if we go to what we just talked about with the hanger diagrams, what we did for an example like this is we just got rid of that 3 groups right off the start. We cut off the unnecessary parts of that hanger diagram. Instead of taking this group of t plus 4 and multiplying it through each of these values by 3, we just get rid of those 3 groups and focus on one group. So what I want to do is get a group of t plus 4, just one group, equal to the amount that it would be equal to. To do that, I have to divide. So instead of multiplying by 3, we'll do the inverse, divide this by 3 and balance it over here. And now I'm down to my one group of t plus 4 equals a third of what those 3 groups equaled. 18 divided by 3 is 6. Now I can go ahead and continue that one-step equation solving it, or honestly, I can just see what the value of t is here in this equation, what that missing amount is. All right. The only thing I wanted to point out too before you do the rest of this practice is 3 and 7 were good examples of that. In 3, you see that we have 5 groups of this group of 4D plus 8. Now, in the past examples that we've done, we've always just had a variable by itself. This isn't a big change, but now our group doesn't just have one variable in it. Our group has 4 D's in the group itself, and now we have to look at having 5 of those. So if we're going to distribute like this, we're taking 5 times 4D. That would be equivalent to 20D. All right? Just keep that in mind. It's going to work the same if you do this strategy here. If we just divide both sides by 5 right off the bat, then we're good to go, and we're left with just one group of 4D plus 8. Now, if you look over here, we've got a negative sign outside the parentheses. Sometimes I think it helps to think of this as a negative 1. All right, when we multiply by 1, we don't change the value of the product that we're trying to find, or we don't change the value of the other factor. So if we do 1 times 3, we still get that second factor, that 3. The only difference here is that it's negative. So we have to think back to our integer rules. We have to think back to multiplying negative numbers. Remember, if it's the same sign, we get a positive product. But if they're different signs, we get a negative product, and that's what's going to happen here. So we have negative 1 times 2k. Negative 1 times 2, those are different signs, so we're going to have a negative amount of negative 2k. That's what this negative sign outside the parentheses is doing, is it's like I said, you can think of it as multiplying by negative 1, or you can just think of it as the opposite. Instead of having 2k in this group, it's now negative 2k. All right. The other thing to think about is with subtraction. So we're applying this negative to the 11. That's going to turn this into negative 11, and we don't want to write minus negative 11. That would look like this and just be kind of messy. We could put it in parentheses to help, but it's still not great. If we're subtracting negatives, it's like adding the opposite of negative 11. So really, subtracting negative 11 is like adding 11. And that would be a much better way to use distribution to rewrite this equation. Okay. Please be patient with yourself. Remember that the more practice you have with this, the better. try to look at solving some of these using this distribution method, using the distributive property to rewrite it first, but also try solving it in some ways that we talked about with the hanger diagrams. Just get rid of those multiple groups at the start and only solve for one group. Again, I'm on Zoom, happy to help. Don't forget to use your time to get this done, your practice problems, and your iReady lesson for this week. Everybody have a great day.